Hey folks, Ms. Gosling here. In this video, you're going to learn about fossil fuels. By the end of the video, you'll be able to quantitatively analyze the energy provided by fossil fuels. So let's go ahead and get started by talking about what fossil fuels are. So fossil fuels are derived from chemical energy, and that chemical energy is stored within coal, oil, and natural gas. To the right here, I have pictured coal, oil, and natural gas. Now, in a fossil fuel power plant, essentially what goes on is we have a big vat of water under which we burn our fossil fuels. So here's my, for example, coal, which I'm going to go ahead and set on fire. So that is going to go ahead and generate steam. And the steam is kind of forced up one pipe into a turbine. And I'm going to go ahead and label that as my turbine. My turbine is then hooked to an electric generator here. And that generator is going to, of course, be where my electrical energy is generated and can then be transmitted out to the community via power lines. So here is your kind of quick, very simplified description of how our fossil fuel power plants work. So some pros of fossil fuels. The power plants that we use fossil fuels in can be made to be large. You can convert significant amounts of power. It's also easy to transport the raw materials. And one thing that I don't have written here, but that I'd also like to mention, is that it is very dependable. That is, the amount of energy produced by a fossil fuel plant on April 5th is going to be about the same as the amount produced on December 24th. So those are pros of fossil fuels, but there also are some significant cons. So first of all, they're not renewable. So one day we are going to run out of coal, oil, and natural gas. We are constantly trying to find new sources of these resources, and one day there's not going to be any new sources left. Another significant cause is that they're a cause of climate change. So fossil fuels, when burned, generate greenhouse gases, which can trap heat in our atmosphere, thus resulting in the heat of the Earth, the average annual temperature of the Earth rising, which has some significant ecological consequences. Another con of using fossil fuels for power is that they actually have other valuable uses. So they're a finite resource. We want to make sure that we're using them in the most valuable way. And the question is burning them for fuel the most valuable way we could be using them? And they can also be used to, for example, generate medicine. And then finally, they do need to be transported from wherever they are mined or otherwise removed from the earth to where the power plant is, which of course is going to reduce the efficiency of that resource as some of that energy is going to go into transportation. So let's go ahead, now that we've introduced fossil fuels and their pros and cons, let's talk about the math. So there are a few equations that you need to know for fossil fuels. So first of all, you need to know our efficiency equation. Eta is energy out over energy in times 100. Secondly, you need to know that we define energy density as the amount of energy produced per volume, given in cubic meter of our resource. So the energy, for example, per cubic meter of coal. And then we also define specific energy, which is the energy per kilogram of a resource. So for example, the energy produced by burning 1 kilogram of petroleum. So let's go ahead and look at an example. A fossil fuel power station has an efficiency of 25% and generates 1,200 megawatts of useful electrical power. The specific energy of the fossil fuel is 52 megajoules per kilogram. Calculate the mass of fuel consumed each second. So let's start with our givens. So we know that the efficiency eta of our power plant is 25%, and that the energy output, so the energy that's generated, and we know that it's output because of the word useful here, also because generates. So our output energy is 1,200 megawatts. And then we know that the specific energy, which I'm going to go ahead and write E specific, of the fossil fuel is 25 megajoules per kilogram. And I do want to mention as well, 1200 megawatts is the same as saying 1200 megajoules per second. And now that I have my givens, I want to go ahead and write down what my unknown is. And my unknown, I've highlighted here, is the mass of fuel consumed per second. So now that I know this, I can go ahead and write my equation. So I know that my specific energy is equal to the energy generated per kilogram. So energy in over my mass. Thus, my energy input, thus my mass, must be equal to the energy required to be input divided by my specific energy. I also know that eta is equal to my energy output over my energy input times 100. So if I rewrite my energy input as my mass times my specific energy, then I can write that eta is equal to my output divided by my mass times my specific energy times 100. So my mass is equal to my 100 times my energy output divided by eta times my specific energy. And now that I have this equation, I can go ahead and sub and solve. So I know that eta, that my mass is equal to 100 times my output energy, or 1200 times 10 to the third, or 10 to the sixth joules per second. And I know 10 to the sixth from that capital M, so which stands for mega. And I'm going to go ahead and divide that by eta, which is 25, times my specific energy, which is 25 megajoules per kilogram. So I can write that as times 10 to the sixth, so 25 times 10 to the sixth megajoules per kilogram. So let me go ahead, I'm going to cancel out my 10 to the sixths, and my mass will be equal to 1200 times 100 over 25 squared. Thus, the mass of coal required per second is approximately 190 kilograms. So there we go. So just a couple notes, things you should expect to see in these fossil fuel problems. You should expect to see you should expect to have to work with efficiency. And you should expect to see either specific energy or your energy density. One of those two things you should expect to see in a fossil fuel related problem. So let's go ahead and talk takeaways. So first of all, in a thermal power station, fossil fuels are used to heat up water, which rotates a turbine connected to a generator, creating electrical energy. Fossil fuels are non-renewable, and energy density and specific energy can be used to determine how much of a given fossil fuel is required to generate the necessary amount of energy. So there you have it, guys. You now know how to solve problems involving fossil fuels. Best of luck, and happy solving.